Hey everybody, thank you for joining us so late in the day and welcome to From Toil to Innovation, Achieving Scalable, Reliable Observability with Neo4j. My name is Lee Yanco. I'm a product manager here at Google Cloud.
And hi everyone, I'm Dan McGrath. I lead cloud products at Neo4j. And today I'm here to share a story about our observability migration. But more than just migration, it's really a story about a mindset shift and how we stopped using observability just to react to operational headaches, and we started using it as an early warning system to drive true business innovation. And to understand why we migrated, we have to talk about where we were as a company a short while ago. And I'm sure many of you here can relate to this. We had a digital hoarding problem. We were treating our observability platform like an infinite storage unit. We're paying a premium just to store unused and unloved metrics. And unfortunately, there was no A&E camera crew to stage an intervention. Our catalyst was actually a symptom of our own success. In my first year at Neo4j, we were mapping out our infrastructure growth for the next year and what our unit economics look like. We were looking at the numbers and realizing that our observability costs were a significant portion of our unit costs, and we're scaling fast with our business. On the flip side, despite our best data hoarding habits, data wasn't being used to its full potential. As an example, we had a customer performance issue in a production workload where we didn't know about it until the customer raised the ticket with us. And that's definitely somewhere where you don't want to be. So we had two simultaneous problems: a rapidly scaling cloud business with high observability costs, and we weren't even using that data for a fraction of its potential, which is to detect business problems and be prescriptive about the responses. The reality is, product usage can accelerate or stall long before the revenue team actually sees it. Often there are already signals in your observability data that are giving you strong hints, whether it's metrics indicating degrading product performance or ones indicating increased usage in less obvious ways. The problem isn't a lack of visibility. The problem is the lag between what the data shows and when you take action on it. Moving beyond reliability, we realized our observability data was a goldmine for business insights. The winning system doesn't just report on the past. It predicts what happens next and tells the teams what to do right now. In our product analytics team, the goal was to answer the three questions that every chief revenue officer asks. Which customers will run out of credits early? Which accounts are expanding fast enough to justify outreach? And which customers need prescriptive intervention before they stall? Manual reporting simply answers these questions too slowly. On top of this, top-level product usage telemetry often misses important context on the customer experience. To solve this latency, we set out to build an automated revenue operating system. Every day, the platform converts product telemetry into a decision, a signal, and a recommendation. And it's built on these four pillars. First, an automated decision engine that forecasts consumption and classifies the account state. Second, looking at acceleration triggers that identify over-consuming accounts before their contract is exhausted. Third is data-qualified leads, so we only send sales the accounts supported by both product data and commercial timing. And finally, prescriptive recommendations that translate those model outputs into specific plays for our go-to-market teams. And this is where it got really exciting. Once we had our data flowing reliably and cost-effectively, we knew observability was no longer just for the SRE team. We're actively moving observability data from being a purely operational tool to being a primary engine for business decisions. Our big theme for 2026 is moving from descriptive dashboards into automated decisions. For example, our account teams have dashboards that they monitor for customer health. And we're building predictive engine that automates that manual review by looking at historical patterns in observability data, things like capacity limits and query performance issues. The system can automatically generate data qualified leads for our account executives. On that, we're also building a prescriptive layer. Instead of just telling an engineer or an account executive that query performance is degrading, the system will explicitly recommend a fix for what it's seeing. To power all this, we're leveraging our own graph technology to build a knowledge graph reasoning layer. This gives our data platform a memory function, allowing the intelligence engine to actually understand the business context behind the metrics. And this isn't just aspirational, it's something we've already built out at a small scale, and now we're moving it to be operationalized more holistically across the company. And the whole engine is built on observability data. A key insight during this build was that solving for the speed of business insight and solving for the cost of observability were actually the same problem. You simply cannot use data for business insights if you don't have a scalable foundation with a stable cost structure. And to understand why this foundation mattered, you need to know a little bit about the scale of Neo4j. So we are the global leader in graph databases. We've been doing it for around 19 years now. But in that time, we go beyond just graph databases, and we have a full graph intelligence platform. Things like graph analytics and data science, AI-powered tools, and an agentic platform that lets organizations spin up knowledge graph-powered agents in minutes. We serve use cases across several personas and integrate natively into your existing stack, whether this means acting as a transactional or analytical database for your applications, or empowering your data science teams to query data sitting in platforms like Databricks, Snowflake, or BigQuery, and often we see customers who have all three at the same time. Because we operate as a massive global service, the infrastructure we build and how we monitor it has to be able to scale with us and our customers' workloads, while still making complete sense from a cost perspective. And I said we operate at a large scale. Looking at just the databases in our platform, we manage around 30,000 databases across the world. And within that cloud database product alone, we have 4 different tiers, ranging from a perpetually free tier for students and hobbyists, all the way up to a virtual dedicated cloud tier that's replicated across 3 zones and explicitly provisioned for large enterprises. What this means is there's a massive amount of nuance in our observability data, as the metrics are entirely influenced between the architectural differences between these tiers. It's a level of complexity that human intuition and basic dashboards start to struggle with. And to see why our monitoring became so complex and so expensive, you have to look at how Aura, which is our cloud platform, was architected. It starts with a centralized control plane for our entire global fleet. Think of it as that single pane of glass for orchestration, provisioning, and security. Beneath that is our data plane that runs on Kubernetes and spans across Google Cloud, and AWS and Azure as well, to meet strict data residency and compliance needs of our customers. So ultimately, we're bridging these 2 worlds together. A control plane that's anchored in GCP, managing many data planes that are entirely multi-cloud. And so we run this heavily distributed, massively scalable Kubernetes clusters across 3 clouds in basically any region our customers need. And this split is great for our users, as it gives them ultimate flexibility on data residency and their compliance needs and latency for where their application is. But from an engineering standpoint, it means we're operating this highly complex, globally dispersed network of Kubernetes clusters. Trying to scrape, push, and aggregate metrics from all these disparate environments into a proprietary vendor without hitting massive scaling limits or unpredictable builds was a nightmare. And that distributed complexity is exactly what drove us towards the shift in OpenTelemetry and using a managed service for Prometheus. And so if I start to layer our observability tools, it's hard to say so many times, observability. If we start to layer our observability tools onto this diagram, and you have to forgive me, I'm just a simple product manager, so I need to keep this simple, otherwise it frightens and confuses me. But you can see, as we move to a managed service from Prometheus, we needed a bulletproof way to extract data from our multi-cloud clusters. And that answer was going all in on OpenTelemetry. We run the OTel collector as a stateful set in every cluster. It scrapes everything and securely ships it back to GCP. But honestly, the biggest win here was the developer experience. Because we use the OTel operator alongside standard custom resources like service monitors and pod monitors, our engineers just write standard Kubernetes manifests. No proprietary agents, no custom config languages. For infrastructure, we keep it simple with open source tools, or open source standards like node exporter and kubestate metrics, and to catch those tricky short-lived jobs, those batch jobs that vanish, we set up push gateways for the collectors to scrape. On the customer side, they can configure custom metrics to be exposed as a Prometheus-compatible endpoint, so that they can be periodically scraped by their own APMs.
So let's talk a little bit about the benefits to using OpenTelemetry compatible monitoring. For those that are living under a rock, OpenTelemetry is the new hotness, one of the most quickly adopted open source projects of all time. All the major observability providers have some sort of interest in OpenTelemetry. OpenTelemetry has fantastic community-created resources and standards. No matter what your runtime is, your language, your framework that you're using, there's some library for it that can give you golden signals, make it easy, standards that you can rely on that other people have vetted for you. It works on all clouds and on-prem. Nobody wants different instrumentation for different environments. And if you're like most Google Cloud customers, you have more than one cloud or more than one deployment area. So OpenTelemetry works everywhere. You have to instrument your applications only one time, deploy them anywhere. It's easy to use, easy to extend. It's the technology your developers are most likely to have experience with when you hire them. And it avoids lock-in. As much as I would love you to stay on Google Cloud, if you ever decide to leave, it's as easy as pointing OpenTelemetry at a different backend. Keep your client-side instrumentation in place unchanged. Let's talk about OpenTelemetry's place in your stack. So here's a Prometheus ingestion pipeline broken down into different steps. There's instrumentation using Prometheus client libraries that create exporters that export metrics in Prometheus or OpenMetrics format, scraped by Prometheus using a pull protocol, and then sent by remote write to a Prometheus-compatible backend. OpenTelemetry does something very similar. It has OTel client libraries that instrument metrics using semantic conventions being standardized metric or signal names, signal labels, signal meanings, so that you don't have to merge differently named signals across different environments. Everything's standardized. Exposed using OTLP, which is a push protocol, that's a standard, that can push directly to a backend of your choice, or you can push it to a collector, that's a more common pattern. That collector can then enrich, process, et cetera, your data before pushing it using OTLP to a backend of your choice. Or you can use OpenTelemetry to create Prometheus metric exporters. OpenTelemetry, ironically, is actually the easiest way to create a Prometheus exporter, and it's one of the more common uses for OpenTelemetry libraries. You can also collect Prometheus metrics using OpenTelemetry, so you don't need a Prometheus collector in the mix. OpenTelemetry can also speak remote write and push to a backend of your choice. And if you have a logging pipeline, like Elk or something else, OpenTelemetry acts very similarly to that. And if you ever adopt things like Profiler or Trace, you can use OTLP to push to Profiler and Trace backends as well. So, a couple different strategies for adopting OpenTelemetry. Roughly in order of how all in you want to go on OpenTelemetry, there's the gateway, the agent, and the instrumentation strategies. The gateway strategy, basically you leave all of your client-side instrumentation, all of your client-side technology in place. Instead of sending Prometheus and logging data directly to a backend, you intermediate it by sending it to an OpenTelemetry collector first. That collector can then run rules, process data, filter data, do some light quota work, stuff like that, before sending to your backends. Why do you want to do this? If you ever decide to change, it's as easy as you don't have to change everything inside of your clusters. You just add a new config to OpenTelemetry. If you want to test out a new provider, you just add a new config to OpenTelemetry. You don't have to go in and rip out your instrumentation. You leave it all in place, and then you just change it at that single gateway point instead. For example, if you ever want to send to another backend, you can just do that with another config. In the agent strategy, instead of having Prometheus collect your metrics, you have OpenTelemetry collect your metrics. It then uses remote write or other protocols to push to the backends of your choice. Most backends nowadays, including Cloud Observability, support OTLP, so you can push data using that instead. And then once you're using OTLP, there's really no reason to keep your old proprietary push protocols. You can get rid of them and just have everything be OTLP, send it to the backends of your choice. The instrumentation strategy, you can keep your Prometheus and logging client libraries in place. Use OpenTelemetry client libraries to create semantic convention signals, which again, super useful because they're standardized names, meetings, et cetera, that then get collected by OpenTelemetry, sent, et cetera. Once OpenTelemetry client libraries are wormed enough in there, you can actually get rid of your old libraries, centralize everything on OpenTelemetry. And then once you're doing that, you might as well just have everything be OTel all the way through. OpenTelemetry can push from the collector or directly from the SDK to a backend of your choice. Pushing from the SDK is super useful because, especially for scale applications where there's a lot of processes running, the memory overhead of running a collector can actually be pretty intense. So you can do things like have your processes push delta metrics, where every 30 seconds they push the change between 30 seconds ago and now, push it to the back end, and then flush, which keeps your memory usage at a very reasonable capped level. Let's talk about OpenTelemetry and Google Cloud. We are all in, and we want to make it easy for you to use OTel. We have managed OpenTelemetry with auto instrumentation on GKE, soon to be GCE and Cloud Run. With a single checkbox, you get an in-cluster OpenTelemetry endpoint. You can use a custom resource to instrument things like ADK-based applications to send semantic convention signals to Cloud Observability. You can also use OpenTelemetry's zero-code auto-instrumentation to instrument Java and .NET and Node.js workloads, soon to be Python as well. Plan to scale backends. So nobody wants to manage scaling your metrics, logging, tracing backend. We have Monarch for metrics and BigQuery for logging and tracing. Let us do the hard work. You just focus on using the metrics. We'll scale the backends. And then expanded AIOps. So announced earlier today, you can set up alerting to push every single alert to Google Cloud Assist, which will open an investigation, try to solve the problem before a human even has to see the alert. So what do you get when you adopt open standards and vendors like us, providers like us? This is a chart of Neo4j's observability spend as a percentage of infrastructure spend. It dropped by about 50%, ongoing savings, open standards. You don't have to adopt everything all at once. You can mix and match. Again, open cloud, open platform. You don't have to use every part of our observability stack. Neo4j uses centralized metric store in Monarch and alerting and cloud monitoring. They use their own self-hosted Grafana for visualization, and they have a BigQuery database for deep analysis that they built themselves. So you can pick and choose, use the parts that you want, leave the parts that you don't.
Thanks, Lee. So I'll bring this all to life just with the last part that Lee was talking about there. And this is what our engineers actually see. Since GCP is handling all the heavy lifting of aggregating our multi-cloud data, our Grafana experience is incredibly clean. By just using environment variables, users can instantly click between dev, staging, and production environments. And to manage this at scale, we build a dashboard as code pipeline using Grafana.net. So to update any of these views, engineer just needs to submit a standard pull request. And so you've seen a little bit on the operational side of the change we've gone through, the technology we're using under the covers. And with that solid foundation in place, as hinted at by Lee just a moment ago, here is where we bring BigQuery in to turn that raw telemetry data we're looking at into action. Looking at this architecture again, the stack remains incredibly simple. We unify usage data, daily credits, balances, and contract terms into a BigQuery feature layer. Then we score that data using BigQuery ML to generate forecasts and detect anomalies. Entirely inside SQL, the pipeline calculates balance history, usage forecasts, anomaly flags, time to burn down, contract alignment, and account state classification to produce final signals and actions. And to make those signals even sharper, we're actively adding in much more granular product telemetry into this process. A huge architectural win for us is keeping the ML layer entirely inside BigQuery. No separate serving layer and no complex orchestration we need to manage. We leverage an Amina Plus model and simply call ML explain forecast to predict the next 30 days of burn. And we follow that up with ML detect anomalies to flag spikes or drop-offs way faster than a human could looking at a dashboard. From here, converting that output into business state is simple math. Balance divided by predicted burn equals our estimated end date. Compare that to the contract, and we know whether they're over-consuming, they're on plan, or they're under-consuming. Ultimately, this engine doesn't just give us another dashboard to stare at, it gives us prioritized decisions. Let's say a customer like Enterprise Pharmaceutical, the system sees they're over-consuming, burning 1,500 credits a day, and predicts they'll hit 0 by August 21st, weeks before their contract is up. But instead of just showing that data, the engine prescribes the exact next steps. So let's walk through an example using the dashboard behind me. Up on top, you can see the core metrics of this fully instrumented account. The contract runs until January 2027 with a 240,000 credit balance. Based on our engine's forecasted daily burn of 1,500 credits a day, they're going to run dry by September. Now, if you look at the orange line on the chart, you'll see a massive spike in daily burn right around October. This is why piping granular product telemetry into the engine is so important. The system is able to cross-reference that spike and recognize it as a temporary data ingestion event and filter out the noise automatically. This gives our go-to-market teams a flawless operating view. Instead of an account executive playing detective across multiple dashboards, the system automatically surfaces this account to them as an over-consuming account and hands the account rep a prescriptive play of launching an expansion motion with that customer within the next 30 days. This single signal stream provides incredible value across our entire revenue operating system. Sales can prioritize expansion conversations using hard product evidence instead of relying upon static account lists. We can spot underconsumption early and apply targeted intervention play and get professional services in with that customer because we've found out they're struggling. Finance gets improved forecasting with burn down expectations that actually align with the contracts we've signed. And finally, leadership can shift from retroactive reporting to operational decision making. So looking ahead, the future of this revenue engine goes beyond basic consumption. We're starting to treat deep, raw observability data as our ultimate leading business indicator. By translating engineering metrics into business context, we can predict customer health, churn, and expansion opportunities far earlier than ever before. Take customer health. Shifts in latency, availability, or replication performance act as our early warning system. We get a real-time pulse on the user experience, allowing us to intervene and mitigate churn before a customer ever raises a ticket. We can also detect workload expansion through things like I/O-related changes long before they ever hit a billing cycle. Ultimately, this is about shifting our signals left. We're moving away from lagging consumption metrics and using leading operational data to actively shape the customer journey. To wrap things up from my side, I want to talk about where all this is heading for us. Having our data properly structured in Google Cloud using open standards means we're perfectly positioned to leverage advanced AI. First, we're incredibly excited about agentic telemetry. With the recent general availability of Neo4j's agent platform, we're looking at a future where our monitoring stack doesn't just alert us to a problem. Instead, the agent can autonomously formulate cipher queries against our own internal knowledge graph, investigate the root cause, and suggest a fix before an engineer even logs into the system. And to process the massive scale of data required for this, we're actively exploring running Gemini models directly in BigQuery. This allows us to handle huge amounts of product analytics needed to power the predictive engines we discussed earlier. We're also evaluating underlying GCP infrastructure required to support this, like dedicated feature stores and inference servers. Ultimately, combining our graph technology with the cloud infrastructure, or Google Cloud's infrastructure, sets us up for a highly autonomous and deeply intelligent future.
So what Neo4j built is very impressive, but it's also a lot of work. How can you get something similar using what Cloud Observability has to offer? First of all, observability analytics, sending your logs to BigQuery, allows you to then run SQL-based ML models on top of them like Neo4j does. Soon, Prometheus and OTLP metric data will be able to export to PubSub. From there, you can also export it to BigQuery to get something similar for your metrics as well. Managed OpenTelemetry, as I mentioned, on GKE, soon to be other runtimes. Getting semantic convention signals for metrics, logs, and traces lets you have consistent signals, which lets you run consistent models because you know what you're querying. Coming soon, label-driven alerting. If you use us for alerting, you can set up an alert where it's one alert that covers all of your services, but based off of the service that's in the time series that triggers the alert, that alert gets routed to the right team. So this is really good for not repeating yourself and for keeping your multitude of alerting rules in check and sane. And then, of course, the planet-scale backends that we offer, so you don't have to deal with scaling, et cetera, infrastructure. Whatever you can throw at us, we can handle, promise. So to wrap it up, to all my fellow data hoarders, there is hope. You can create an observability platform that sparks joy. You can change your observability platform from one that creates toil to one that drives innovation. Thank you.